This is Sarah Bowman, class of 2016, and I'm going over Chapter 5 in the textbook, question number 16. So the question says, an automobile engine slows down from 4,500 revolutions per minute to 1,200 revolutions per minute in 2.5 seconds. Calculate its angular acceleration and calculate the total number of revolutions that the engine makes in this time. So the first step is to convert revolutions per minute to radians per second. And so you're given the original velocity and the final velocity. And so for the first one, you take the original velocity of 4,500 revolutions and you multiply it by 2 pi radian and then divide by 60 seconds, which gives you 471 radians per second. And you do the same thing with final velocity, so you put 1,200 revolutions per minute times 2 pi radian divided by 60 seconds, and that is 126 radians per second. So now that it's converted, you can go ahead and start the problem. And you are going to be putting it into the second kinematics equation. So as it's written, the second kinematics equation gives the answer for velocity. So we are rewriting it to be final velocity minus original velocity divided by time equals acceleration, because we're looking for the angular acceleration. And when you put the numbers into that, you have 126 radians per second minus 471 radians per second divided by 2.5. And your answer is negative 138 radians per second. The next part of the problem asks you for the total revolutions in that time. So we are using the third kinematics equation. And that also gives you the answer for velocity. So you have to rewrite that one. And so the original equation reads final velocity squared equals original velocity squared plus 2 times acceleration times angular position. So what we're looking for is revolutions, which is angular position. So we rewrite it to be angular position equals final velocity squared minus original velocity squared divided by 2 times acceleration. And when you put all of the numbers that we found into that, you have 126 squared minus 471 squared divided by 2 times negative 138 equals 746 radians per second. And so that's the answer to the problem, but it's still in radians. So you have to switch it into revolutions, and to do that you go back to the train tracks and you do 746 divided by 2 pi radians, and your answer is 119 revolutions.